At this very moment, a radio signal is crossing a gulf so enormous that by the time the machine answering it speaks back, an entire day on Earth will be gone. The machine is not new. It is not sleek. It is not powerful. It is not supposed to still be alive. It was built when disco was on the radio, when home computers were rare, when most of the scientists now studying its data had not even been born. And yet this aging spacecraft, drifting far beyond the protective bubble of our sun, is still forcing modern science to confront a possibility it does not fully understand. And now the story has become stranger, because Voyager 1 did not literally make a dramatic U-turn and head back toward us. What happened is, in some ways, more unsettling than that. To stay alive, the farthest human-made object in existence had to reorient itself in deep interstellar darkness, using hardware NASA had long ago written off as dead. A tiny, delicate act of survival, a pivot, a correction, a desperate mechanical adjustment on a machine more than 15 billion miles from Earth. And almost immediately, that survival story collided with another one, the continuing stream of data from a region of space no human being has ever visited, describing a signal scientists still cannot fully explain. That is why Voyager 1 matters in 2026. Not because it is old, not because it is famous, not because it carries a golden record. Voyager 1 matters because it is still doing something nothing else is doing. It is our only active outpost in interstellar space. It is the only living witness we have placed beyond the Heliosphere, the giant magnetic bubble inflated by the sun that surrounds the planets and helps shield the inner solar system from the broader violence of the galaxy. Every other spacecraft in history did its science from inside that bubble. Voyager 1 is outside it. It is not looking at the frontier. It is inside the frontier. And that changes everything. When Voyager 1 launched on September 5, 1977, nobody expected this. The mission was ambitious, but it was not mythic. The spacecraft was supposed to visit Jupiter and Saturn, collect extraordinary data, maybe survive a few years, and then fade into the black. NASA was not building an immortal machine. It was building a planetary probe. A brilliant one, yes, but still a probe with an expected lifetime counted in years, not in generations. Then the spacecraft refused to behave like a short mission. It tore past Jupiter and transformed our understanding of the giant planet and its moons. It passed Saturn and kept going, decade after decade. As nations changed, technologies collapsed and were replaced, and entire scientific careers began and ended. Voyager 1 kept transmitting. It became not just a mission, but a survivor. And then in 2012, it crossed one of the most important invisible boundaries in the solar neighborhood, the edge of the heliosphere. To understand why that matters, forget for a second the pretty textbook diagrams. The sun does not simply shine. It exhales. Constantly, it throws out a flow of charged particles and magnetic influence called the solar wind. And that outflow carves a giant cavity into surrounding space. Everything we casually call our solar system lives inside that influence. The planets, the comets, the dust, the missions, the history of our species as a spacefaring civilization, all of it developed inside the sun's protective domain. The outer boundary of that domain is not a painted line. It is a dynamic frontier, a shifting contact zone between our star and the galaxy outside it. Voyager 1 crossed that frontier in August 2012 and became the first human-made object to measure interstellar space directly. That alone would have secured its place in history. But the spacecraft did not stop there. It kept moving, and over time, as scientists learned to read the thin stream of data still coming home, Voyager 1 began to reveal something unnerving about the space between stars. It was not as quiet as expected. For years, researchers had ways of estimating the density of interstellar plasma near Voyager's path. But those measurements were sparse. They depended on occasional shock waves moving outward from solar eruptions, cosmic disturbances that briefly lit up the local environment and gave scientists a limited snapshot. Useful? Yes. Continuous? No. Then something changed. buried in Voyager 1's plasma wave data. Researchers identified a weak, narrow, nearly monotone emission that persisted from 2017 onward. Not a dramatic burst, not a one-time anomaly. A faint, steady hum. That hum became a scientific opening no one had before. Instead of waiting for rare events, scientists suddenly had the possibility of tracking interstellar plasma density over a long stretch of space with regular sampling. In other words, humanity was no longer taking occasional photographs of the environment between the stars. It had begun, in a limited but real sense, to monitor the weather, and what that weather suggested was not emptiness, but texture, not stillness, but fluctuation, not a sterile void, but a medium alive with structure, turbulence, density shifts, and behavior that cannot be reduced to the old mental image of silent, uniform nothingness. This is where the story becomes more than a curiosity, because if the interstellar medium pressing against the heliosphere is more structured and more dynamic than we once assumed, then the heliosphere itself is not just an abstract border in a physics paper. It is a living shield interacting with a rough external environment. That matters because Earth and every other planet in the inner solar system lie downstream of that shield. Scientists are not saying Voyager has discovered some instant threat to life on Earth. That would be reckless, but they are saying something more intellectually serious. The better we understand the region outside the heliosphere, the better we understand the system that moderates how our solar neighborhood interacts with the larger galaxy. And Voyager 1 is still our only direct reporter from out there. What makes the hum so powerful as a narrative is also what makes it powerful as science. Nobody can yet say with full confidence exactly what physical mechanism is producing it. One possibility is that the signal arises from thermally excited plasma oscillations. Another is that it may be related to quasi-thermal noise. Both are real scientific possibilities. Both would tell us something valuable, but they do not mean exactly the same thing. And until the mechanism is pinned down more firmly, the signal remains both a breakthrough and a question, mark a rare combination that is irresistible to scientists and almost impossible for storytellers to ignore. But even that is only half the reason Voyager 1 feels so gripping right now. The other half is that the spacecraft itself is fragile in a way that makes every new discovery feel temporary. In late 2023, Voyager 1 began sending back nonsense. It was alive. Its carrier signal was reaching Earth, but the engineering and science data coming from the spacecraft was corrupted. Unreadable, effectively gibberish. Imagine staring at the heartbeat of the most distant machine ever built and realizing it is speaking, but no longer in a language you can decode. That was the situation NASA engineers faced. They could not go there. They could not reboot it by hand. They could not pull a panel, replace a chip, reseat a connector, or swap a board. Voyager 1 was already more than 15 billion miles away, and every exchange with it was painfully slow. A radio signal took roughly 22.5 hours to travel one way. You did not test a theory in an afternoon. You did not try 5 fixes before dinner. You sent an instruction into the dark, waited nearly a day to learn whether it arrived, then waited nearly another day to see what happened. Each idea cost time. Each mistake could become permanent. Eventually, engineers traced the problem to corrupted memory in the flight data system and began an extraordinary workaround, moving software code into new memory locations and carefully reconfiguring the machine so it could package and send understandable data again. It was, in the truest sense, remote surgery across interstellar distance, and it worked. By 2024, Voyager 1 had resumed returning usable engineering data, and later scientific data followed as well. The ancient spacecraft had not simply survived. It had come back online after what could easily have been its final breakdown. That alone would have been enough to make Voyager one of the most astonishing engineering stories ever told. But the mission was not finished being dramatic, because then came the thrusters. To communicate with Earth, Voyager 1 has to keep its antenna pointed with exquisite care. That sounds simple until you remember what kind of machine this is. An almost half-century-old spacecraft drifting in deep space. where tiny orientation errors matter, and every correction depends on thrusters that have been aging for decades. Over time, some of those thrusters began to suffer from clogging in small internal fuel pathways. Engineers had switched between different thruster branches before, using one backup after another as the years passed. But by 2025, the situation had become more urgent. The set then handling key roll control was itself at risk. And that mattered for a very specific reason. Roll motion is how Voyager keeps its antenna aligned using a guide star. Seen from Earth, that movement is almost like a record turning, just enough to stay locked in position. Lose that control, and you do not merely lose elegance. You risk losing the link. So NASA engineers revisited a set of roll thrusters that had effectively been considered unusable since 2004, after power to internal heaters had been lost. For 2 decades, those thrusters were treated as gone. Then someone asked the question that keeps old missions alive. What if the original diagnosis was incomplete? Engineers began to suspect the issue might not be permanently dead hardware, but an electrical path that had effectively put the system in the wrong state. If they could restore that state, the heaters might come back. If the heaters came back, the old thrusters might be usable. And if the old thrusters were usable, Voyager 1 might regain a critical backup just before a major Earth-based communication antenna in Australia entered a long upgrade period. The timing could not have been much tighter. If the active system failed, while command capability was limited, the consequences could have been mission-ending. So they tried it. Across more than 15 billion miles, they sent commands, waited, and watched, and then the temperature on the long-dormant thruster heaters rose. The supposedly dead system responded. Voyager 1 had, in effect, turned itself just enough to stay in the fight. Not a cinematic spin, not a science fiction reversal, something more real, a barely surviving machine, forced to rely on forgotten muscle memory in the dark. That alone would have justified headlines, but at almost the same time, the science pressure intensified. In April 2026, NASA shut down the low-energy charged particles experiment on Voyager 1 to conserve power. This was not because the instrument had failed. It was because the spacecraft is losing roughly 4 watts of electrical power per year, and the margin has become thin enough that every choice now feels like triage. With that shutdown, Voyager 1 was left with 2 remaining active science instruments, one that measures magnetic fields, and one that listens to plasma waves. Think about what that means. Humanity's only live laboratory in interstellar space is now speaking through a smaller and smaller set of senses. And yet those senses remain precious. NASA says the instrument shutdown bought roughly a year of breathing room, while engineers work on a more ambitious power management approach. For the Voyagers, a strategy intended to keep them warm and productive with even tighter energy budgets. There is even a possibility, if that effort succeeds, that the instrument turned off on Voyager 1 could one day be switched back on. No promises, no guarantees, just one more improbable attempt to buy time for a spacecraft that has made a career out of exceeding every expiration date anyone ever gave it. That is the emotional center of Voyager 1 in 2026. It is not a dead, relic-whispering nostalgia. It is a still-functioning scientific witness operating on borrowed time. The data matters because the window is narrowing. Every year, the power falls. Every year, another subsystem becomes a hard decision. Every year, the engineering required to keep the mission alive becomes less like routine maintenance and more like balancing a civilization's longest-running experiment on the edge of silence. And there is another reason the clock feels so real now. On November 18, 2026, at 2:16:07 a.m. Pacific Time, Voyager 1 is expected to reach a distance of 1 light day from Earth. Pause on that. 1 light day. Not a poetic phrase. A physical fact. That means light itself, the fastest thing the universe allows, will need a full 24 hours to travel from Earth to the spacecraft. A simple command sent from our planet will not even arrive until the next day. And the reply, if there is one, will not come back until the day after that. 2 days for a single conversation with a machine we built in the 1970 and launched before the modern digital world existed. No human-made object has ever reached that distance from Earth while still alive and communicating. That is not just a milestone. It is a psychological threshold. It stretches the relationship between creator and creation to a scale the human nervous system was never designed to feel. When Voyager 1 answers us, it answers from yesterday's edge of reality. By the time we hear it, the spacecraft has already moved on. The thing we are listening to is always, in a very literal sense, no longer there. And still it keeps going. It moves outward at roughly 35,000 miles an hour. It does not cruise through some dramatic tunnel of stars. Interstellar space is mostly darkness, distance, and particles too sparse for human intuition. There are no welcoming landmarks, no rescue plans, no maintenance bay waiting ahead. Just an aging probe, a thinning power supply, a narrowing stream of information, and a silence that grows more inevitable with every passing year. But before that silence comes, Voyager 1 is still handing us pieces of a puzzle we cannot solve from Earth alone. That is the part people often miss. We love the romance of deep space. We love the golden record, the greetings in dozens of languages, the image of a tiny ambassador drifting forever. But the most important thing Voyager 1 is carrying is not symbolic. It is empirical. It is data from a region of space we cannot sample any other way. And because no replacement mission will reach interstellar space anytime soon, what Voyager is collecting now may stand alone for decades. The next probe built for that purpose, even if funded quickly, would still need a very long time to get where Voyager already is. So when the spacecraft sends back evidence of a persistent plasma signal, whose exact origin is still debated, that is not just another weird space mystery. It is a rare scientific condition, a live unanswered question from a place we cannot revisit on command. The medium between the stars is speaking in a tone we can hear but do not fully interpret. And the only instrument listening from inside that environment is nearly 49 years old. There is something almost unbearable about that. Our newest telescopes are stunning. Our software is more advanced than anything the Voyager team could have imagined in 1977. Our simulations are better. Our sensors are smaller, faster, smarter, but none of that erases a simple truth. Right now, the only active machine sampling interstellar space directly is an old probe running on dwindling power, protected by engineering decisions that have become more delicate with each passing year. It is not the newest thing that has gone the farthest. It is the one that survived long enough. And maybe that is why this story hits so hard. Voyager 1 does not flatter us. It humbles us. It reminds us that exploration is not always about the biggest rocket or the flashiest launch or the most photogenic mission. Sometimes it is about endurance. Sometimes it is about keeping the signal alive one more year. Sometimes the most important discovery is not a dramatic photograph, but a faint recurring note in a sea of plasma, a pattern so subtle that without patience, no one would have heard it at all. That is what makes this moment feel so eerie. A spacecraft launched during the Cold War, repaired from across billions of miles through days-long conversations, kept alive by reviving hardware once declared dead, is now approaching a communications threshold no civilization has ever crossed before while still returning data from the space between stars, including a persistent signal that science has not yet fully pinned down. If that sounds like fiction, it is only because reality occasionally embarrasses fiction, and the ending is already on its way, at some point in the early 2030, unless engineering miracles keep extending the timeline. Voyager 1's available power will drop too low to support its remaining instruments. One by one, the senses will close. One day, the final usable scientific reading will be taken. One day, the final command will be sent. One day, the final answer will begin its long trip home. The signal will arrive. It will be recorded. And after that, there may be nothing but carrier silence, or nothing at all. But until that day, Voyager 1 is still out there, still correcting, still listening, still measuring, still telling us that interstellar space is not just an empty stage around the stars. but a real environment with density, turbulence, and behavior we are only beginning to grasp, still reminding us that the frontier did not end when the planets became familiar. It only became quieter, harder to read, and much farther away. So no, Voyager 1 did not simply turn around in the way a headline wants you to imagine. It did something more impressive. It stayed oriented. It stayed alive. It kept the line open. And because that line remained open, we are still receiving clues from beyond the sun's protective cocoon, clues wrapped in a faint signal whose full meaning remains unsettled. One machine, two working science instruments, more than 15 billion miles from home. A full day for light to reach it, another day for the answer to come back. And somewhere in that vast delay, a message from the oldest frontier we have ever touched. The universe outside our neighborhood is still stranger than we expected. And the question is no longer whether Voyager 1 has already made history. The question is how much history it still has left to make before the silence wins.